We're working through the entirety of the proof of how the quadratic equation exists, so that we all know everything there is to know about how that happens, and you can justify why it works. So everyone, please head your paper with whatever we're on, 624.
Where does it come from?
And you could go ahead and say deriving the quadratic if you want. You don't need to write the big fancy word of derivation, but write the initial ax squared plus bx plus c equals 0.
Yeah, what are derivatives?
A derivative? It's when you well, if you really want to know.
No, my mom, every time I go home from out, she's like, did you learn about derivatives? Did you learn about derivatives? I have no idea what she's talking about.
I'm not going to give you like 5% knowledge because it's just going to confuse you more. We'll get, well, not in this class. We don't have a need to get there in this class, but if we have time, we can get into some derivative work. So, what would be the first thing we'd want to do if we're working with an equation involving variables and constants? Sorry, this needs to be equal to 0. And as the book shows us, first thing we want to do is isolate the constant term on its own side, right? So get rid of that c from the left side. We're going to push it.
The quadratic formula. There's no r.
Wait. So first thing we do, subtract c from both sides. Now without our German friend from YouTube singing us through how to do this, do we know what would be the best strategy next if you don't look in your book? That's why I did not scroll my screen. Yeah, we have a common term of x, right? But we have x and we have x squared.
Square root ax plus b.
You can factor the x out.
You have ax plus
We
b.
could factor out a and x, right? They decide they're going to isolate the x squared term, right? And they divide out the a. So realize that if we factor out the x, that doesn't actually help us. Because imagine if we do divide by x, I'm going to then have ax plus b. This is also going to be divided by x. And then I have a new constant term over there. It's just not helpful. It makes things actually a bit more complicated. So now, there are multiple ways to get through this. Some are better than others. So this, we could force it to work. That just means it's not your best idea. So let's factor out that a. Because what that then does is it just changes the coefficient of your x and gets rid of your coefficient of your x squared. Well, this is how I have to stand to right up here. I just have to like. But I've learned that if I'm putting for disc golf, I need my pinky toe pointed towards the back. We're talking about stances.
The more you know. That'll be useful in the future.
You throw the disc in the basket. Now notice, now sorry when my A's look like 9s, notice that we now have that A in the denominator, right? Like what we're used to with that quadratic formula.
Multiply by a. Multiply by a.
Now hold up. So we go back here.
Now for x, so let's take minus c multiplied by 4a, and if you now add
No, wait, he takes a different route.
But don't be scared. Just take a close look to the left side and you see there's a binomial formula.
So this is what I wanted us to figure out.
This is the square of 2ax.
So I should drag this down so you guys can see it more easily. And I know it's somebody else's video, but whatever, I can get him hits maybe.
Not more easily. Well, I mean, technically, don't do it for it's been 10 seconds. You gotta drag it back up, otherwise it's caught. Go back.
It's a freeze frame. So, and which actually, if I Google, so Google generates its own freeze frame images off of YouTube videos. So for what it's worth, like that is like you can do that. You can just screen capture essentially. So we divided by a. Instead of dividing by a, he multiplied by 4a. Why?
Maybe a perfect square.
So
then
he's forcing a perfect square.
Whoa.
So if he forces that perfect square and multiplies by 4a on both sides, that then creates 4a squared x squared plus 4a bx plus b squared. We have perfect square out here. We have perfect square out here. And we can factor it into perfect square form. So hold on, let's compare that with this. So if we take our magic rectangle, whatever you want to call it, the generic square, generic rectangle, whatever we call it. You can't really call it a square. Well, if we're going to force it into a perfect square, then yes.
Would any one of these be used to solve the quadratic
Sideways
equation?
diamond.
As long as you don't break any algebraic rules.
Sideways.
So, Satya, to answer your question with a broad answer, as long as you don't break any algebraic rules, you can do anything you want.
So number 4 could have been what we had to use for the quadratic equation.
No, because the quadratic equation isolates x. That's the point of the quadratic formula, is it's giving you x. This is not yet there. That's a equivalent form. Because, remember, we're not doing anything here. When you do something on both sides, you don't do anything, right? So this is the same, but it's not the final version. So let's look at what happens here then. Instead of multiplying by the 4a, and I wanted to show us both versions since we've been talking about this like all year because it's a funny song, but then this is so much different. Notice that this still forces into perfect square form. They have perfect square here for just x squared. Perfect square over here, because I can square root that whole thing, because 4 is a perfect square, b and a are both squared. So I can make that perfect square. Either way you take it, doesn't make a difference. Here we end up with 2ax plus b squared. Here we end up with x plus b over 2a squared. We will end up in the right form. So if we keep following the CPM process, just so we have it written down, and really, I don't care which version you take. This is why I wanted to stop us for a second here and then give you the options of which one you write down. So we keep the left side the same for a while. What's happening over here on the right side?
We're just kind of like switching things around and changing them up, making them easier to read.
Yeah, but what else happened? There's something big.
Some flip. 4AC. Look.
To go from this step to that step, well, this term flips places, right? That was the first thing you guys said, is commutative property, right? Don't forget about the negative, which they turn into a minus. But then, what was applied here if we use CPM terms? A giant one. So again, we didn't do anything, quote unquote, right? We didn't do anything. They multiplied by a 4a over 4a. They didn't do it on both sides. Remember, that's just 1. So you see where that came from?
Yeah.
So then, why'd they do that actually?
So that's easier to make sense of.
Common denominators, right? So that my fractions could be combined. So all they were doing was forcing common denominators to happen, and then solve for x. So I'm showing you different ways. Okay, it's not right or wrong. They both work. Okay, don't get like worked up or judgmental. You're like, why didn't you just? You could.
It's not all the way. It goes like all the way till.
Well, let's compare how many steps are over
We
here.
have only one x, so the next step would be to get rid of the square. And if the right side is not negative, the square root must be one solution. But as an alternative, because minus the square root leaves the same if you square it. So we write plus minus, and now we are at the point where it only takes 2 more steps to solve it for x. And if you look to the left side, you know what will be next. Subtraction of b and division by 2a is giving us a formula for x. Okay, and
So 1, 2, 3, 4, 5, 6, 7, 8, 9.
His is better.
Okay, arguably. So I'm not here to tell you better or worse, whatever. Like, that's all your brain. That's your decision to make in your brain. But I want you to write down one of these proof processes. So if you don't want to write, I'll full screen that again. If you don't want to follow this process, you may copy down the proof process from the video. But I want one of those to be in your notes so you have a justification for how we derive that formula. And as I will say, until I go to my grave, As long as you don't break any algebraic rules,
I will.
you can do anything.
So I can fly.
No, that breaks algebraic rules. You don't have enough lift to combat the force of gravity. Now, if you would increase your amount of lift,
You can use a jetpack.
what if you what?
What if I want to buy the world?
I don't think currency conversion rates will allow that to happen. But I mean, you can try.
If two people on opposite sides of the earth drop a piece of bread, would make the earth a sandwich.
Technically,
I just need you copying things down right
very big set.
So when CPN, square roots, they show an absolute value, whereas, I need to figure out this dude's name. When he shows the square root, he just immediately jumps to the positive negative. So that's actually kind of where that step difference happens. Is in the video, he doesn't show this step. With the square root, that creates the two options. Because really the quadratic formula has two versions. The plus and the minus version.
What do you do to go from the fourth step to the fifth step in the video?
Oh, he's just rewriting that. So he didn't do anything. He's just rewriting it to expand out. He condensed 4a squared x squared into 2ax squared. He expanded 4abx with the 2ax and the b, and then b squared just stayed how it was, but now he can show that it's all perfect square. Like he forced perfect square equation. Not really forced, I mean it works.
It's kind of like an equation. You went with, and then
So there's going to be a lot more times in your mathematical career where you're kind of asked, like, okay, don't jump straight to the answer because you can't. You got to do stuff in between. Like, you could not jump straight from ax squared plus bx plus c to x equals. You can't do it. You can't factor out the x because there's an x squared and an x. You got to work through the process.
And then what about 5 to 6?
Square roots, both sides. Well, so are you saying going from
Yeah, going from 5 to 6.
going from here to here? Again, he didn't do anything. He just took this left side and rewrote it as perfect square form. Then, going to the next step, he takes the square root. That's why there's 2 empty gaps on the right-hand side of work being done. He didn't actually do anything. It's just rewriting. Well, if you skip over the rewriting steps. If you can go straight from 4a squared x squared plus 4abx plus b squared, jump all the way down to 2ax plus b, with the other side already, I mean, yeah, you could skip steps, but it's asking to make mistakes. Yeah, the more steps you skip, the more you're just begging to make mistakes. All right, questions? I wanted to make sure I give you enough time on that. No. No. So basically,
This is from Dorf.
okay. Now we're getting a little redundant. So we might come back to him. Maybe not. Let's figure out the roots of these equations. So I guess I'll leave it on this board for a moment. A, B, and C, you will notice, are 3 different types of our quadratics. You can use whatever form you want to derive those zeros. But we need to find the zeros for all 3 of those equations. So please write down the original first and then factor it. For B and C, please write down the original first. Really for all of them, but Nathan had already skipped it for A. Write down the original first always, because otherwise you're asking to make mistakes.
Well.
Find the zeros. Just factor it. This is gonna seem easy because we like have done it for a while, but this is a skill that tends to be difficult for students. So that's why we kind of go slow with expecting you guys to master. What type of quadratic is A?
Perfect square.
Oh, perfect square, right? So this becomes x plus 3 squared, which means your zeros are x equals just negative 3. Right? So that parabola only has 1 0 point. Now, raise a hand, please. Who can tell me what B is? Why is it special? Difference of squares, which means it becomes what?
One's positive and one's negative.
Yeah, one's the addition, one's the subtraction.
Positive and negative 3.
Really, I should have written negative 3 then positive 3, because this one would generate negative 3, that one would generate positive 3. So what has been done to this parabola?
It's like probably like reflected across the axis.
No?
It's been lowered.
It's been lowered by 9. That's it. We should be able to look at the equations. And first up, you see that your zeros are mirrors of each other. They're reflections of each other. But when we compare to the parent function, what you said to me was that it's been reflected, which means it would have flipped. That means there would have been a negative here. So be careful how you say things. If on a mastery, I might ask you not to find the zeros, but tell me what has happened to this parabola. Now I ask you in A, what has been done to that parabola? Has it taken a vertical shift?
Mm-hmm.
Yeah. What else?
It's like
What's the B term tell you? No.
It's width.
See, this is why I figured we needed to review this.
Is it
On
width?
your paper, somewhere like off to the side, ax squared plus bx plus c. The c tells us a vertical change has been made. If c is the only thing, like if we don't have a bx, then all we've done
It's side to side, isn't it?
b, now it's not a, like I can't say it's moved 6 to the right, like it doesn't work that
It kind
easy.
of goes like along the thing.
Yeah, moves along its own parabola.
Yeah, b technically is a shift parabolically.
And then A's intensity.
Yeah, no space for y. So when we change b, and we can go into Desmos and do this, our parabola from the center point will actually shift along the inverse parabola of negative x squared. Not, yeah.
Oh, that's so weird.
So when so I start with my x squared parabola right there, and I start changing b, my parabola will move like this. The center point moves on that line. Now, with A, because we know it's perfect square, and we have just negative 3,
It doesn't hit the
because we've done a vertical and a parabolic shift, what's really happened here is it's shifted parabolically down, and then it's also shifted up, and then it only hits once. So then in C, oh, sorry, what does A do? What's A do? Intensity, right? It's that tightness. So however you want to write that, either intensity or slope, it really it changes the slope of the line. However you want to say that.
That a ray is a parabola with infinite intensity.
It really also just changes the width of the parabola at any given location. So it changes your intensity or width, whatever you want to
What if
say.
it has infinite? What if A is infinity? Does that
It
mean?
can't be. That's not a number. It's not
No,
counting.
but if it was an infinite.
Now,
if
C-
the number of values is infinite. With an infinite value, what would
So, like,
C.
Chris. Okay. Because eventually, after you travel infinitely up, then it was like.
Now C doesn't work as well. right? Because technically, by what we know, C quote unquote doesn't have any zeros, but we know more than that now.
You pull it.
It's not that 5D. It's 78 out.
Which isn't a thing, but don't worry about it.
How do I deal with C?
Now you're your friend.
Well,
Is there an easy way to do
Pull it
this?
back.
you usually don't.
No, you do.
Subtract the 9 and then you
Yeah. And then you do like 3i.
subtract the 9.
X squared equals -9.
X squared.
So I make y 0 first, right?
Oh yeah.
Then I can subtract 9 from both sides. Then x equals the square root of -9,
Or 9.
We just.
which we know is 3i, but since it's a square root, there's also the
So
negative
plus
i,
3i.
or negative 3i.
Or
Plus or minus
9i now.
Now, here is the shortcut I'm afraid to show you. When I go to approach C, oh yeah, of course I'm still going to show. I'm afraid to show you, but I'm still going to do it.
That's not a good.
I did not mean to clear. Sorry, that's my bad. I did not mean to clear. So B, right, was x plus 3, x minus 3, because it's a difference of squares.
We
Now-
just solve that and then be like, there's the
Yeah,
answer.
Does
I.
C,
Yeah.
What
is
piece of
happening?
tape.
yeah, there's another piece of tape or something on here.
It's like invisible.
What if it's
Alright, I
actually
got it.
damage?
No, I got it.
That's a
Um,
That's all.
C, does C have a B value?
No.
So my terms in my FOIL process have to cancel out the B value, just like they do in a difference of squares.
So Christopher was right.
That's
You
it.
just do it, but you put an eye on it.
You just do it, but you put an eye on it. Because you know you can't square root the negative.
You shouldn't have shared this information.
So if we had x squared plus 16,
Oh my god.
it'd be x plus 4i, x minus 4i. Shortcut.
You already
Yeah, but not with the imaginary.
That's-
Because I don't think I connected it with just how easy it is to
Wow.
factor. Because before break, guys, I think before break when we were dealing with imaginaries, we went through the solution process for all of them, do the square root of the negative, and actually work, like, if it's a perfect square, you don't have to. You can take the shortcut. Cool?
learn the hard part first.
So, check out A1. Questions you actually have to think about here. Closed sets. Who can remind us what a closed set is?
If you like multiply it by
If you
itself,
do the thing by the thing, it turns into.
Who wants to use real words?
Then
Explain what a closed set is. Jacob.
In any
Isn't it when you use some sort of
So I told you something is closed under. Here, I'll make it even easier. If I told you integers are closed under multiplication, what does that mean?
that it's still an integer even after you multiply it.
Yeah, the result.
The result is the same as what you use for each term or whatever.
Yeah, so your inputs into the whatever you're doing, the function really, because multiplication is a function, it's an operation, will generate the same type of term. So are integers closed under division?
No.
No.
Not necessarily.
3 divided by 2, right? Integer divided by integer. Do I get an integer?
No.
No. So closed means the output term will match the type of input term under certain operation. So when we think about rationals and irrationals, that's what we're just saying. We're going to talk about these problems to try to determine are they closed or not. So if you want to dive into those, I'm going to take Satya's question, but go ahead and look at 81. What's that?
If it's open,
Integer
it's
is
probably
entire quantity. So cannot be partial, cannot be decimal, cannot be fraction, but it can be negative. Whole numbers do not involve the negatives.
I had a joke of like, I don't like the word integer because it has a negative connotation.
Entire number. Integer. That's my trick for remembering. Integer, entire number.
Too much hard to say.
What's a natural number?
It includes zeros. Whole numbers don't include the... Or no, sorry, other way around. Whole numbers include the zeros, naturals don't. Natural numbers are countable.
The counting numbers 1, 3,
8,
and 6. Those are all the natural.
You cannot count 0, so that's why it doesn't.
There aren't any more natural.
Wait, what are
numbers.
natural numbers?
1, 3, 6, and 9. Those are the only natural.
Satya, stop listening to Chris. He's making stuff up. Natural numbers are anything you can count.
Those are the only ones you're allowed to count.
Exactly. Are we working on 81, hopefully, please?
For 8? Or no, wait, there's an 8.
I don't think I need to spoon feed it to you. I think you can read and think.
1, 3, 6, 8, 9.
So,
Those are the only countable numbers.
it works you through a couple questions to help you generate your answer. So if we're trying to find the area of that triangle, we'd be multiplying. If we're trying to find the perimeter of that triangle, we'd be adding. Right? So to answer A about multiplication and or addition, we can just find the area and or the perimeter.
I know the area. It's radical 3 over 128.
But it's also asking for
Yes.
Everyone's favorite. So we're just the irresponsible type?
I mean, we already have calculators. You don't all need to be calculating it, but I...
Okay, so the area is square 3
No, that doesn't help with the
divided by
decimal.
128. Every approximation is 0.013.
What's 8 times 8 divided by 2?
So basically,
8 times 8 divided by
Very
it
good.
says
Or
approximately.
it's radical 3 over 2.
That's it should be radical 3. Dividing is the same as multiplying by 1/2, so it would be radical 3 over 128.
No. Okay, so you multiply 8 and 8. Wait, 8 and 8 makes 64. What? I put addition.
Decimal approximation is 3 plus.
Should you ever add the denominators?
What?
I'm just posing the question. Should we ever add the denominators?
When you're
No,
adding.
never.
But like, if
No,
you get 1 over
no,
8 plus
no.
2 over 8, and now you have 3 over 8.
Right, we don't add the denominators.
at the bottom part of
No.
Yeah.
Oh!
Denominator.
Our area was...
Sorry.
Yes.
Yeah, that's depressing.
So I have mega faith that you could work through perimeter and area. That's not really the question. The question here is, are rational numbers, right, anything that can be written in fraction form, closed under multiplication and or closed under addition? Same thing with irrationals. So are there numbers up here that are rational and or irrational? Like what's what?
2/8 and 1/8 are both rational.
So then radical 3 over 8 is irrational? Because radical 3 has no approximation, or only has an approximation, it has no exact value. So when we think about the area, and we multiply these things, do you get a rational or an irrational?
I got an irrational.
Irrational?
Little.
Yeah,
area.
1/8 times
With
6.
area.
Oh, Eric.
When you
Yeah,
multiply,
it's radical 3 over 128.
Bless you.
Irrational.
Yeah.
But we're multiplying a rational by an irrational, so we can't really find out whether or not they're close into the same thing.
so for your actual answers, if you want to verify, your area should be approximately this,
Yeah.
and your perimeter should be approximately this.
Not that I got.
Now for rational numbers, if we ignore the height of the triangle, rational numbers are closed under multiplication and addition. We could figure this out real quick. Fraction times a fraction, fraction plus a fraction. We're just going to get back out a fraction. But irrational values, do I always get an irrational if I multiply two irrationals?
No, yeah.
Yeah, like radical 3 times radical 3, right?
3. I get 3.
Now, if we go and we look at C, though, think about what C is asking. When we add a rational and an irrational,
It will always be irrational.
why?
Because, like, no matter what you do, I don't know how to explain
So
it.
can you flip your statement around? I know what you're struggling on, to say, like, the opposite of what you're thinking. So how can I
By
turn
proving the opposite.
how can I turn an irrational into a rational?
By making it stop.
But how?
By adding
By multiplying by an irrational. Right? If I take an irrational and I don't make it rational, I gotta multiply by another irrational, probably the same. If I add, it doesn't work.
Wait, what's by times?
So like radical 3 plus radical 3, you get 2 radical 3. Still irrational. So that's why if I involve an irrational number, even if there is a rational number, it is going to be irrational always.
Like, you're not changing the ending of it.
Correct. So then what about multiplication of a rational and an irrational? Like radical 3 times 8, or radical 3 times half.
No.
Always irrational.
Wait, what? I got 4.
Pi to the 18th.
But you have to think about every situation that could. So all because you type in a square root doesn't mean it's an irrational. What'd you type in?
Oh, I just realized it is that.
You went to square root of 16.
I know.
Not irrational.
I forgot. No, I forgot.
He
that
didn't
I-
close. He didn't close his
I
radical
didn't
2.
close my
He did radical 2 times 8, so it did radical 16 because your calculator's dumb. So we're not really going to do 82. We're going to talk about it real quick. 82 essentially, in a way, wants us to make like a flowchart sort of thing to categorize types of numbers. I don't think we need to. So just take a moment and look at these different number categorizations to think about like, oh yeah, complex numbers compared to integers, what makes that difference? Well, for a complex number to be different than an integer, what does it need to involve? An imaginary number, right? So imaginary numbers then generate complex numbers. Like, so just think about how these all relate to each other. We were just talking about the natural versus positive versus negative. Natural numbers are all your positives. It's like your countables. 1, 2, 3, 7, 4, like whatever. It's all your countables. Whole numbers also involve
Sarah.
0. So the natural number set is inside of the whole number set because natural just takes away 0. It says 0 is not a natural number. If you start to number things, you don't start at 0. If I start to say the students in my class, I don't say 0, 1, 2, like that doesn't make sense.
0. Levi doesn't count.
Because I don't.
No, that 0 is like the wall.
Whenever you need to count students to pass out papers, I know that's how you're
But then 0 also on its own is in the set of whole numbers and real numbers and rational numbers. And now, positive and negative, that gets to a big argument. 0 is neither, right? It's neither
We'll say
positive.
that whole numbers.
And hey,
positive numbers are in whole numbers.
to wrap this up real quick so you can work on your homework. Londa, I don't know. Londa multiplies square root of negative 7 with square root of negative 7, and she thinks it is 7. Well, so, we all know why Londa's wrong, right? Multiplying two identical radical terms just removes the radical. So, I don't know. This is just one of those, like, if you guys were standard sophomores, some of you might make this mistake and we should talk about it. I really think we're done.
Radical negative 1.
You think we're dumb?
No, done. So here's the proof it wants you to write. So humor me for just a moment. Here's the proof they want you to have. Radical negative 7 times radical negative 7. Actually, this is useful for when these terms are different numbers. Really becomes radical -7 times -7. Now, that does not work with addition. That's the biggest rule break that I see students make. This can only condense under the radical with the multiplication. So then, negative times negative becomes positive, and that's how we get our positive result. So if you want to write down another example that might be more useful to you, write down something like radical of -3 times radical of -2 actually becomes radical of 6. -3 times -2, which then still is irrational, but really this is super simple. We know that. We know we're just going to get -7.
So long as the steps you can take to get -7.
Do you even realize that you just interrupted an adult teacher in the middle of a sentence? Like, I don't even interrupt you when you're in the middle of a sentence. I respect you. What I care for you to realize is that you can merge multiplication under the radical. You cannot do it with addition. That's all I care about from 83. And we're done. So we're done.
You almost threw your
That's all I care. Because, like, guys, that is the rule that students try to break. If you have, like, radical 4 plus radical 9, it's not radical 13.
Oh, that's the rule, not like sharing food during lunch. Or.
What?
You said that's the rule they try to break.
But that's not a rule.
Do you think we're not allowed to share food at lunch?
I mean, there are so many people.
Exactly.